Welcome back, trigonometry. This is C-squared mathematics, and today what we're going to be doing is 5.5 graphs of sine and cosine. So now we are actually going to see what these graphs look like, what do these trigonometric functions look like, and then in the next couple days we're going to look at tangent and the other graphs, the reciprocal graphs, and that's going to be the week. So today, bell work, the homework quiz, and then our actual 5.5 lesson. Very simple examples. I'm trying to not make it as complicated as possible, but I hope it's enough to get you through your homework. So the bell work, this is the only bell work question I have. Again, I don't want to make these videos too long, and this is not as fundamental as 5.4, so I really hope it's going to be shorter. With that said, that's why I only have one bell work question. I really hope you go through the homework and you try your best so that you are prepared for the homework quiz. So what did we learn? I'm just going to recap. How do I go about this problem? I want to recap sort of what we learned yesterday. We learned that cosine of theta, no matter what, now will equal x. We learned that sine of theta equals y, and that tangent of theta equals y all over x. That's what we learned yesterday. That's the big trinity for trigonometric functions. Okay, and those are the only three I'm going to find. What does that mean for us? That means if we're given a point like this on Math Excel, we're given this, and there's a circle and so forth. If I want to find sine of theta, even though I don't care what the theta is, sine of theta will always be my y coordinate there, okay? Because that's what we've deduced, that's what we've figured out, especially if this length right here r equals 1, okay? So that means I literally just say negative 24 all over 25. That is my answer. And now notice this is negative, and which quadrant are we in? This is where the point is right here. Which quadrant are we in? We're in quadrant 4, which means all trig functions are negative except for cosine. So if we do cosine, let's see if it's actually going to be positive. Cosine of theta, we said cosine of theta is my x. Well, here it is. Cosine of theta, that's my x. So that's 7 all over 25. Is it positive? Yes. And then tangent of theta is going to be negative. That's going to be sine all over cosine. So sine negative 24 all over 25 all over cosine, which is 7 all over 25. We could also say y over x. This is y all over x. And then the 25s go poofy, negative 24 all over 7. Could I technically build this triangle? Like, could I technically find out what side is the hypotenuse and so forth? Well, the hypotenuse of clearly is 25 because that's adjacent all over hypotenuse. This is opposite all over hypotenuse. And so with these numbers, I do have three side lengths, 7, 24, and 25. And we have negatives because of this, okay, because we're in the quadrant 4 here. So I hope that kind of rings a bell of really what we did yesterday. That's really the biggest chunk here. I don't want to go through any more bell work questions. I want to conserve the time, but I hope that makes sense. So let's erase. You have 25 minutes on this bell work. Sorry, on the homework quiz. You have 25 minutes on the homework quiz. Of course, open notes, 5 questions. Try your very, very best. Use your notes. Use the unit circle that I showed you. If you need a reminder, go to classwork. Google Classroom, Classwork, scroll down. It's right here, trig table of common angles. And then you can click on that. It helps you. And then, of course, the unit circle. You also could use the unit circle on this trigonometry unit circle. I also gave you that link as well. So you could use this one. I usually use this one because it's just on decimals already, so it's nice. Okay, whatever you need to use in order to succeed, please do that. Review your answers at the end. Send any partial credit. Now remember, if you have an 85% or above in my class, you don't need to take this. So please review Synergy, because if I grade and you did not have an 85% or above and you did not take it at the end of the week, okay, then that means I'm going to mark it 0. Okay, I'm going to mark it 0 anyways. But if you're in 85% or above, I won't mark it 0. I would just mark it excused if you don't take it. Okay? So make sure you know that. All right, what we're going to be doing is just graphing. Hopefully you don't mix up sine or cosine, and that's really the main part. Don't mix them up. We're only going to be doing these. We're going to be using decimals, of course, and then we're also going to be just using straight up math by hand calculation. This is actually a really, really fun lesson. I really like going into the graphs of sine and cosine. So let's get started. What does the graph of sine look like? I'm going to build it by hand, and then I'm going to go to decimals and show you what it looks like. Okay. This is the basic parent graph function where a, b, c, and d are constants, and b is neither zero. Neither a nor b is zero. Okay, neither a nor b is zero. Now, what is the x-intercepts? We're going to ask that. What is the y-intercepts? Minimum, maximum, domain, and then, of course, range. Now, notice here this graph. Before I even graph anything, notice this graph, guys. What is different? What you should see is that it's completely different in the fact that my x value is in radians. Now, your x-axis is still your x-axis. It's not like I'm changing the numbers here. Okay, pi is still a number, right? Pi is still a number. And so what we really have done here is just make it into a radian axis. And that's fine. Like, you can do that. And by the way, decimals does it too. And I'll show you that in a little bit. But we made it into radian axis. But it also, you should notice that these are our quadrantal angles. These are our quadrantal angles. Pi over 2, pi, 3 pi over 2, 2 pi. So it's almost as if you split that unit circle, like you took it apart like as a chain, and then you whipped it like on the XY axis. What is it going to look like? What will that look like? Let's find out. So I'm going to be using this unit circle right here. Okay, so if you want to pull up your unit circle, that's great. I'm going to be using this one. I'm going to be referring to it over and over and over again. All right, so let's get started. Now, what we're going to be asking is sine of something, okay? Sine of something. So I'm going to look right here at just the very center. If I ask you, let's actually, before we do that, let's do this and make this 1 because we don't have axes here. They're not labeled. Let's just do that, okay? That's fine. If I ask you, what is sine of 0 radians? Can you tell me? What is sine of 0 radians? Well, if I go over here, sine of 0 radians, this is 0 radians, 0 degrees, okay? Sine is my y-coordinate, okay? So sine of theta equals y, and then cosine of theta equals x, right? So keep that in mind. So look at my y-coordinate here. Sine of theta equals something. So let's just look at sine of 0. Sine of 0 radians, the angle measures 0. What do I have? Sine of 0. Well, I look at this point. I look at this evaluation. These points are evaluations. What is it? What is that y? That y right here is 0. So what is sine of 0? Sine of 0 is 0. So I'm going to put a dot right there. Okay? All right, now let's go to pi over 2. What is sine of pi over 2? Sine of pi over 2. So we're going to be up here, 90 degrees, sine of pi over 2. Again, look at your y-coordinate. That's what sine is. And we see that's 1. So we're going to go back. Okay, sine of pi over 2, that's 1. Okay, so I'm going to put a dot here. See kind of what we're doing here? And I go back, sine of pi, because that's what my next one in line, sine of pi. So sine of pi, what is that? Look at my y-coordinate. Okay, it's 0. So 0 again. So we're going to go back here and plot 0. That's my evaluation. Okay, 3 pi over 2. Let's go. 3 pi over 2, sine of 3 pi over 2, it's -1. Okay, -1. So I'm going to go over here, -1 all the way down here, and then sine of 2 pi. So sine of 2 pi, okay, we're back here. This is still 360. This is technically 2 pi still, and it's the exact same thing. So 0. So I'm going to go back over here. I'm just going to say 0 again. Now, what do you notice? What you notice is kind of looks weird. This is our sine graph, and I'll try to do the best I possibly can, but this is what it's going to look like. Something like that. Okay? That's what it's going to look like. It looks like a wave. The reason why it looks like a wave is because it's actually a sound wave. And by I mean a sound wave, I mean a literal sound wave. So I'm speaking to you right now, right? When you're on Google Meets, you see the little green bars kind of like go up and down. they're sine waves. Okay, if we were in class, we would have this awesome activity involving music and involving trigonometry. And we would listen to music. We would graph like different lyrics and everything on Desmos. It would be amazing, but sadly, we're not on campus, so we can't do that. And so, unfortunately, that burdens me a lot because that's one of my awesome activities that I've created. But still, sine is a sound wave. Me speaking to you is a sound wave. If you pluck a string of a guitar, you see it kind of vibrate, the string. The reason why it vibrates is because it's a sine wave. It goes back and forth, and that's also a periodic function. So we can actually graph the other half of this if we wanted, but just flip it. So we can actually flip this whole thing almost and just, or kind of like reflect it. Not a true reflection, but sort of. And we can kind of piece it together. So in this case, I'm going to piece it together as such because it's just going to be the opposite of everything. So it's going to look something like this. And then now we can kind of piece it together. I'll try to do it to the best of my ability. Like that. Okay? So this is two whole lengths of the sine graph. Two whole lengths of the sine graph. Okay? Now I'm going to go to Desmos and show you what it actually looks like. This is actually restricted. This is restricted at negative 2 pi and 2 pi. But it does go on forever. Okay? It will go on forever. You just need to restrict it. So if we go to my graph, this is also given to you on the classwork page. If you go over here, right underneath, if you go to trigonometric graphs, Desmos, this is the general trig graph. So right here, I have them all listed out, and you can actually play around with these, and we will soon in a little bit. But this is what your normal sine graph looks like. And now notice Desmos even has your radians there for you. Your axis is in radians, which is great, you know. So I put it in radians, pi over 4, step pi over 4, and then you actually have 3 pi over 4, pi over 4, 2. And so it's actually pretty great. I like that, you know. Pretty awesome. But you notice that it goes on forever. It will go on forever, and so forth. Okay. Awesome. I actually don't want the grid. I'll keep the grid. That's whatever. All right. So that's what the sine graph looks like. It is like a whip. It's kind of like a wave. And so some of your homework assignments will actually have that as well. Now, what are the x-intercepts? That's what I'm really concerned about. The x-intercepts, at least in this case, is going to be 2 pi, negative 2 pi. It's going to be negative pi, and then 0, and then pi, and then 2 pi. Now, what do you notice? It's every pi integer. Okay, it's every pi integer. So now, of course, this goes on forever. I have it restricted, but your x-intercept is actually every pi integer. So really, we can say n times pi, where n is an integer, and you can just multiply, pick any number for n, and then it will repeat that many times. It will repeat that many times. Your y-intercept is, of course, 0. It only has one y-intercept, it's 0. Your minimum is negative 1, your max is 1. Your domain goes on forever, but of course we have it restricted here, but it does go on forever, and your range is from negative 1 to 1 in interval notation. Okay? How we feel about that? Hope pretty good. Hope pretty good. Okay? So that's your sine graph. Now let's erase. Let's go into my cosine graph. What is that going to look like? We're going to do the exact same things. We're going to be looking at the same parent graph function, x-intercept, y-intercept, min-max, domain range, of course, with the same graph. So now, let's find what cosine of 0 degrees is, cosine of 0 radians is. We're going to go back here, 0 radians. I'm going to look at my x coordinate now, and that's 1. So I'm going to go over here, and I'm actually going to do 1. So I'm going to relabel this stuff. So I'm going to put 1 right there. Perfect. Now, cosine of pi over 2, I'm going to look at my x coordinate. That's 0. So go back here. It's going to be 0. And then cosine of pi, it's right here, my x coordinate, negative 1. So right here. Okay. And then Let's go back. 3 pi over 2. So cosine of 3 pi over 2 is 0, so it's going to go back. And you should probably guess it. Pi over 2 is going to be back at, or 2 pi. 2 pi is going to be back at 1. So 2 pi is going to be back at 1 right here. Boom. Now you may think, oh, that's absolute value, Mr. Carlson. What's your problem? And it's actually not. Okay, so I'm going to try to do the best of my ability. I have to almost try to do it freehand. That's honestly the best I can do, okay? Like that's the best I can do. I'm going to show you the Desmos graph anyways, but let's reflect this. I keep saying reflection, but it's not a reflection. Let's just kind of do the other side. Let's do that. Let's see if this is better. Okay, that's a little bit better. Okay, man, this looks like a drunk dog. I mean, for real, like it looks awful. Let's go back to trig and this Desmos. Let's now look at cosine. So if I look at cosine now on top of sine, it's actually that. Okay, that's what cosine looks like. If I take it away, that's what it looks like. Now it's the exact same points that I had. These are the exact same points that we had before. So if I go to here, these are the points that I have. If I go back here, if I go back here, these are the points I have. I can even do the negative points if I wanted to. They're the exact same negative points, right? Perfect. Now it goes on forever, correct? Sweet. So that's trig. That's the basics of trig for cosine and sine. I mean, really, that's it. Now, those are the foundations. Now, notice what I have here. Here I have A is 1, B is 1, C is 0, and D is 0. Now, what does that mean? That's what we're going to mean, because now what we're going to be starting to learn is the transformations. Okay? But before I get to the transformations, before I actually play what it will look like, I'm going to show you this graph. This is the graph I made about maybe like last summer or something. I can't remember, but I made it, and students really liked it. This is like all the trig functions together. And so when we actually go through the secant, cosecant, cotangent, you'll see this as well. These are all the trig functions together. And for sine here, I actually did restrict it. Okay, so it almost looks exactly like what we have on, and then I can label this, pi divided by 4. And so that would help us, So I can label it like that. And so these are my exact points that we had. These are the exact points that we had before. And students like this one better because it's restricted already. And since it's restricted, it's easier. And you can put cosine right on top of it. Cosine, you can have the exact same points that we had before, and so forth. Yeah. So that being said, let's go to. You can use this. It's on a classwork page. It's on Google Classroom. I really like using these because they're just nice. They're a little short and sweet. And then this is the reciprocals, which we're going to do in a couple of days. But if you go back here, let's just play sine. If I play sine, now watch what the A does. What do you think the A does? Before I even teach it to you, what do you think the A does? Just think. You should probably be thinking it makes it stretchy, okay? Right? It makes it stretchy. And that's exactly what it does. It makes it stretchy. Okay, so now I'm going to pause this. Okay, now what do you think the B does? When it does, what do you think the B will do? Just look at it. What do you think it does? You should probably be thinking, well, it seems to me that it just kind of goes horizontal. Okay, but in a weird way. It doesn't shift horizontally, it kind of shrinks horizontally. Okay, and then it kind of stretches out horizontally, right? So think about that in your mind. I'm going to pause this and we're going to go to the C value. What do you think the C value does? Think about what it does. Actually, this is a weird step. Look at that. That's garbage. Okay? Think about what it does. What do you think? Why is this doing it so weird? All right, it's just okay. That's a little bit better. You probably should be thinking it shifts the whole thing. So what's the difference between C and B? So this is B. Okay, think about it. And this is C. Students always get C and B mixed up. And I'm actually going to put names to it in a little bit, okay? But one is a horizontal shift and one is not. And I hope you're saying that C is actually the horizontal shift. C is the one that's the horizontal shift, not B. Okay, now I'm going to pause that. Let's go to D. What do you think D is? This one's very easy. Okay, it moves the whole thing. But then students still get this confused. Ready? Students get A and D confused. So what's the difference between A and D? That's A. It's really, really, really big. But this is D. I'm going to play them both at the same time. Sort of weird, right? Really weird, okay? So let's pause those. Okay? That should give you a general idea to what we're going to be doing when we're actually shifting these. So let's finish up the x-intercepts for cosine. This is going to be the exact same thing, almost the exact same thing, but it's actually n times pi all over 2. That's your intercepts. Your intercept for y is 1. This is 1, negative 1, and literally the exact same thing, negative infinity to positive infinity, and then negative 1 to 1 inclusive. Okay, so that is my intercepts for my cosine function. That's my maximum, minimum for cosine function, domain and range. Nothing really new there. What we're going to be doing is now looking at what we call amplitudes, periods, and phase shift. So what is the amplitude, period, and phase shift? I'm going to show you. These are your formulas, so I'd be writing them down. So your phase shift is what we call the transformation. Okay? So the transformation is your actual phase shift. Your C and your B transform it in a way. Your B value, though, is what we call the period. Okay? It's actually the length. Okay? It's also one full cycle, but it's also what we call the length of the wave. If I can spell length correctly. Okay? It's the length of the wave. So that's that stretchy part. So if we go back to B, okay, and if we just picked on B right here, okay, this was B. It's that stretchy part. It's actually the length. Now watch. I'm going to pause it right here. Now notice between the peaks, okay, it's really, really big right here, but as it gets closer, it's now becoming smaller. That's what we call the period, okay? That's what we call the period. It's different than the B value. It's different than the C value. The C value literally shifts the whole thing, whereas the B value just shifts the waves. Okay? So those are very, very important distinctions here. Okay, and then the A is what we call the amplitude, and this is actually, truly, what we call the volume. Because again, all trigonometric functions are what we call volume. It's the sound wave. Okay, so amplitude gets amps, like when you plug a guitar into an amp, it amplifies it because it raises the volume. So since it raises the volume, it's big. But when it gets smaller, the volume's smaller. Of course, the amplitude is smaller. Okay, so this is what the graph looks like. The amplitude is just this little bit right here. So if I go back, your amplitude, notice your A, it's kind of shrinking it. It's not moving the whole thing. It's just kind of stretching it. That's what it is. It's stretching it around. Okay, but it's not moving the whole thing up and down. If I want to move the whole thing up and down, that is what I call the D value. Okay, the outside value. That's what it means to move the whole thing up and down. So that's what I have. You don't have the d value here because we really don't even touch it, but technically you would have a plus d and it would kind of move this whole thing. So it'd move this whole thing up and down. Okay? So that's the basics. Get these formulas down because we're going to be using the formulas, because Math Excel is not just going to ask you, hey, graph this, and then you have to graph it or choose which one, but it's also going to ask you what's the period, the amplitude, the phase shift, and so forth. And we have to pull those out. So before we do that, I just want to let you know that this is also very, very convenient. That when we're given a function like this, your a is the it's not the aptitude. Okay, it's the amplitude. Sorry. It's the amplitude. Okay, and then the phase shift is C all over B. So we need to make sure that the phase shift is also what we call the horizontal shift. So I know we say this is the phase shift, but it's technically called the horizontal shift as well. And then, of course, the vertical shift is just with that D, and this B value is the length, kind of the stretchy part. Okay, it's the length of it. Okay, yoga pants are basically a great form of of a trigonometric function because they stretch and then they go back to its original position. It stretches and it goes back to its original position. Okay. Another thing that can be used is those paddle balls. You have a ball with a string and the paddle. You paddle it back. It's like stretches, goes back, stretches, goes back, stretches, goes back. You know, and so that's a trigonometric function right there. Okay. So let's go through this, and then we'll actually start going through the graphing portion. We'll go through this, and we'll start going through the graphing portion. And I'll also go through the steps for graphing. I'll go through the different ways to how to find period and the period of a sine or the amplitude of sine and so forth. Okay, so first off, I want to just kind of preview. I want to find, before we fill out this table, I want to find what the period is, the amplitude, and then the phase shift if it has it. Okay, so I'm going to do it up here. What is my period? Okay, my period equals 2 pi all over b. Okay, that's my formula. So this will be our first step, finding the period, finding the amplitude, finding the phase shift. So what is my b value? My b value is actually right here. It's just 1. So that means this is 2 pi all over 1, which is just 2 pi. So this is a normal, straight up, just the length of a sine graph, 2 pi. Your normal length, the normal period for any sine graph is 2 pi. But sometimes, depending on the other transformations, it can get stretched, it can get thinned out, whatever. Okay? So let's go through the amplitude. The amplitude is simply just the absolute value of A. That looks like junk. The absolute value of A. Now where's your A? Your A should be the one that's right before the trig function. So it's the absolute value of A. Even if it was negative, it doesn't matter. In this case, it is 1/4. So that means my amplitude is 1/4. And then I also want to find what we call the phase shift. And that equals C all over B. Okay, so my C value in this case is, be careful, in this case it's actually negative 3 pi all over 2. Now why is it negative? Because my normal trig functions have a built-in negative. So what this is saying is really x minus a negative 3 pi all over 2, which of course a negative to a negative gives me a positive, but the problem doesn't show that. That's the problem. You need to deduce that this is your C value. Okay? That's your C value. Now what's your B value? It's of course 1. So that means it equals negative 3 pi all over 2. So your phase shift is what we call the starting point. Okay? And so since your phase shift, that's your starting point, we start there. Okay? That's where you start. So right here in our table, this is the same as our phase shift, right? We start here. Now, how do I do this? Well, first of all, I would strongly encourage you to use Desmos. Math Excel is going to tell you how to do this all by hand. And I'm sure you guys could. I'm not going to. Okay, I did it on my key, but I'm not going to here. Just use Desmos and start plugging this in. That's it, okay? So watch. I'm going to go to just your normal, let's just go here, okay? Your normal trig function. Let's actually label this stuff. I have sine, right? So my a, we said my a was 1/4. So I'm going to erase all this, 1 divided by 4. My b, we said, was 1. Okay? My c, we said, was negative 3 pi all over 2. So negative 3 pi, okay, all over 2. And make sure we're in radians here. So I'm going to go back. Okay, we're in radians. We're solid. So I can use radians. That's my c value. And then my d is 0. I don't have a d value here. So this is what the graph actually looks like. Okay? This is what the graph actually looks like. And now that I know what the graph actually looks like, watch this, guys. Watch. We're given a table here. I want to know what the output is, the y-coordinate of negative 3 pi over 2, negative pi over 2, 0, pi over 2. I want to know what that is. I can absolutely just plug these values in for x on my TI-36X Pro. I can do that with Desmos as well. But you know what an easier way to do it is? Just look at the graph, because the graph will tell you. Watch. So negative 3 pi over 2 is right here. What's my output? It's 0. This is, we want negative pi. What's my output? It's 0.25. Now, they'll want a fraction, so we have to change it to 1/4. What about negative 2 pi over 2? It's 0. And then what we're given also is 0. So what is actual 0, like sine of 0 in this case? It is a negative 0.25, which will change to negative 1/4. And then, boom, we want pi over 2. Those are what corresponds to my table. Negative 3 pi over 2, negative pi over 2, 0 pi over 2. And that's it. That's all I need to do. I just need to take this y-coordinate there, that y-coordinate. Oh, I can't do that. That's lame, okay? So let's go over here. Let's actually label these y-coordinates in fractions. So this was 0 we got, sorry, not negative. We got positive pi over 4, and we got 0, and then we got negative pi over 4, and then we got 0 again. Okay? So notice just this. Just notice this. What happens? It bounces around, right? Because it's periodic. It's a trig function, okay? So I find that really, really helpful. That's awesome. I love doing that, okay? So please use your technology. You have it available. You have Desmos available. Technology isn't bad. It's not cheating, okay? It's available to us so that we can learn more about the trig functions. Okay, but make sure you're in with sine, okay? If you chose cosine, that will probably be bad. Don't mix them up. You're going to have a bad time. All right, so let's erase. Now, actually, let's get to finding the amplitude, period, phase shift, and let's try to figure out which one it is. Now, this is what Math Excel will more than likely do. They'll more than likely give you A, B, C, or D. There's a couple that you'll have to actually graph like by hand and everything on Math Excel, but most of the time it's A, B, C, or D, and you'll have to figure it out, okay? The first thing that they're going to ask is what's the amplitude. Right here is the amplitude, so that's just 1. A equals 1. My period is going to be 2 pi all over b. So what's my b value? My b value is actually 2 right here, so this is 2 pi all over 2, which in this case my period is pi. Okay, not bad. That means it has a length of pi. That's what it means. It has a whole length of pi. All right. Okay, now my phase shift is going to be c all over b. Be careful of the built-in negative. So my c value is pi, not negative pi, but pi. And then my b value is 2. So this right here is where you start. So this, your graph must have a starting point of pi over 2. So does c have a starting point of pi over 2? No. Does b have a starting point of pi over 2? No, it has a starting point of 0. So really you're left with a or you're left with d. Okay, so which one is it? Well, which one has a length of pi? Well, they both have a length of pi. Pi over 2, and then if you take 3 pi over 2 minus pi, you get a length of pi. This is 270 minus 90, you get 180, and 180 is pi. Same thing here. But there is a difference here. 1 is kind of flipped like this. That's A. And then 1 is not. 1 is kind of like this. And then you have to go back to your A value. Is your A value negative? Why does that matter? Go back here. Watch this. Watch. What if I make my A value negative? Ready? What happens? What happened? It flipped. Okay? It flipped. So, and if I go to my normal trig functions, let's just pull up sine. Ready? Pull up sine. What happens if I put a negative here? Flips. Okay? Now, our normal trig function does look like this. It goes up first and then down if it's positive. So, this is a positive one. Is it going to go down first and then up, or up first and then down? It's going to go up first and then down, which means A is not my answer. It is D. Okay? So that process of elimination is really what you guys are going to be doing for literally your whole homework. You'll have harder questions on there as well, but that's the majority of your homework, okay? So let's go and just crank out these. I'm going to go fast. Let's just crank them out. So your A value is 6, so absolute value of 6 is 6. Your period is going to be 2 pi all over B. So this is 2 pi, and then your B value is 5. So this right here is your length. That's a little bit harder, but your C value is going to be pi, and then all over B, which is 5. So this is where you start again. Okay? So let's see what we got. We got these, we got these. Now, don't get confused. This just kind of goes on forever. What they're really caring about are like connecting the dots here. Just connect the dots where I'm kind of going through, kind of outlining here. Don't care about the extra stuff. That's just going to confuse you. So where do you start? You start with pi all over 5, right? So that means I can't do D because it starts here. Don't want to do that. Can't do B because it starts here. Can't do that. Let's switch to red. This is a lot of blues, I feel like. So that means it's either this one or that one. Now, what's the length? Okay, what's the length? And how do I know the length? Well, the length is 2 pi over 5. And the length is both 2 pi over 5. From here to here, it's 2 pi over 5. From here to here, it's 2 pi over 5. Okay, so the length, the period can't help me. So then I look at the amplitude. What's the amplitude? The amplitude is that thing that stretches. So if this is my normal sine graph, okay, your amplitude is this. Okay, that's your amplitude. It's not the whole thing, okay, but it's just that. So that means this needs to go up 6 units. Which graph does that? C, and not A. Because right here, C goes up 6 units. From here to here, it goes up 6 units, and that's what I want. That's your amplitude, okay, your A value. Hope that's clear. So let's continue. Let's go through this one. Try to do this one yourself. I'm going to pause the video. Just check it yourself and see if you can get it. All right. Welcome back. So what is going on here? First off, it's kind of like a trick because this is D. Okay, so this 3 is not your C value at all. Okay, remember your C value needs to be in parentheses, so it's actually your C value 0 here. Okay, your C value 0. Make sure you know the C value is in parentheses. So this is actually your D value. Notice there's no parentheses here, so I can't do that. Now your amplitude is easy too. Your period is 2 pi all over your B, which is 1/2. Multiply by the reciprocal. 2 pi times 2 is 4 pi, so that's your length. And then your phase shift is C, which is 0 all over 1/2, but it doesn't matter because it's just 0, which means it's not going to shift at all. What does that mean? It means that we're going to look at these, whether or not they shift horizontally. They don't shift horizontally, so the phase shift doesn't help us. The period is 4 pi, so it can't be B because that's 2 pi, and that's the length. And then it's positive 2, so it can't be D because that flipped it down. So it's either this or that. Now the D is the one that raises it up and not raising it down, if that's a thing, raising it down, bringing it down. So it's raising it up. So that means it has to be A because of the 3. It raises up. And that is our kind of pivot midline right here, the 3 there. Okay? Hope that makes sense. Sweet. Let's do a cosine graph one. We'll do 2 cosines and then we'll be done. Okay? So amplitude here is 1/2. I'm going to go a little bit faster. That's 1/2. My period is 2 pi over b, which is 2, which is pi. My phase shift is going to be c all over b. Notice a built-in negative, so negative pi all over 2, which is b. Multiply that by the reciprocal, so that's going to be negative pi all over 2 times 1 all over 2, which equals negative pi all over 4, and that is my starting point. Okay, that's going to be my starting point. So I look at my graphs. Okay, obviously it can't be b and d. Why? Because my starting points are not negative pi over 4 here. They're negative pi. And so since it can't have a starting point other than my phase shift, that means, remember, I have to start here. So that means it can't be these. Now, what does it mean for here? Okay, negative pi over 4, negative pi over 4, 1, 1. Okay, so they're both really good. What does that mean for us? Okay, well, notice one thing, your amplitude. Your amplitude right here this is 1, and then right here is actually 1/4. So this tells you that your amplitude is just 1/4. This tells you your amplitude, if that's 1, that tells you your amplitude is 1/2 because it goes down to 1/2. Which one is it? Well, our amplitude's 1/2, which means it's C, not A. Okay? Hope that makes sense. Let's go on to the next one. Try to do this one by yourself. I'll give you a second, so pause the video and then come back and I'll have the answers. Pause the video if you need to. Okay, so this one is kind of hard. The reason why it was hard is because you had to really pay attention to the units of the graph. Okay, so right here, amplitude is 4, period is 2. Don't forget the built-in negative, so that's opposite. Negative 4 pi all over pi gives you negative 4, and that's where you start. Now, all of them start at negative 4, so your phase shift doesn't really help. But because the amplitude is positive, these are both flipped, so it can't be that automatically, which means you're really stuck with D or C. Now, it can't be D because look at the amplitude just a little bit bigger now, a little bit tighter. The amplitude here goes up 2, okay? Goes up 2. If that's my midline of my cosine graph, it goes up 2. Now here, my midline is right here, and it goes up 4. 1, 2, 3, 4, and that's 5, which means it has to be C. It also is C because if you look at the period, it's 2 across. Now this one is 2 across as well, but the amplitude is really what gave it away. Okay, so that one was a little bit more tricky because you had to really pay attention to the units. Now, of course, could you graph these on Desmos? Sure, but I'm telling you, it's really not going to help you. Okay, you need to kind of analyze the graph this way. When it actually asks you to do a graph, then maybe graphing on Desmos would help. But when it asks you A, B, C, or D, then that's not going to help. This is probably the best way. Okay? Awesome. We learned how to understand the graphs and variations and transformations of sine and cosine, as well as vertical shifts of the sine and cosine curves and how it relates to the trigonometric functions. Okay, we also looked at periodic behavior and how it just kind of goes back and forth and kind of fluctuates over and over and over again. Okay, so remember, retakes for the basic trig quiz are this week. Just email me. They're going to be due on Friday. Take it whenever you need to. Okay, just let me know. And then your homework is just 5.5 graphs of sine and cosine. Be prepared for the homework quiz tomorrow. Do your homework. Okay. Without further ado, this is C Squared Mathematics. See ya.